A modern U.S. Bradley fighting vehicle costs roughly $6 million to field. It is a symbol of conventional dominance, heavily armored and built to withstand a direct assault. Yet, in a recent engagement, one of these machines was destroyed by a loitering munition costing just $3,000. The same imbalance has reached the air. An F-15E Strike Eagle, a pinnacle of aerospace engineering, was neutralized when a drone swarm deployed a simple net into its engine intake. For a century, military dominance relied on building increasingly expensive, centralized platforms. The logic was that superior, massive hardware would always provide the ultimate deterrent. Today, that economic logic has collapsed. Adversaries are achieving a 2,000 to 1 cost advantage. A strike that costs less than a used car can now erase an asset that takes years of national budget to replace. Western forces are not losing a race of engineering or skill. They are losing a war of accounting. Defending against these cheap attacks has depleted Western magazines. High-tier interceptors like those in the THAAD system are being launched faster than they can be restocked. In recent conflict zones, years' worth of SM-3 and SM-6 missile production were burned through in mere days. A single week of high-intensity defense is consuming nearly a decade of industrial effort. The manufacturing bottleneck is severe. These legacy interceptors require 18 to 24 months of lead time to build, making rapid replenishment a physical impossibility. When each interceptor costs millions and each incoming drone costs thousands, the defender is guaranteed to run out of ammunition long before the attacker runs out of targets. This current crisis is driven by an unprecedented innovation in decentralized swarm intelligence, a system often called the Jellyfish Swarm. Legacy drones use a centralized architecture. One pilot links to one aircraft. This creates a single point of failure. If jammed, the mission ends. The Jellyfish Swarm replaces this with a peer-to-peer mesh network. Drones share control and data among themselves without a central hub. This networking allows the swarm to act as a single organism. If a target maneuvers, the nodes communicate instantly to reposition, effectively herding the aircraft into a kill zone. Destroying individual drones does not stop the swarm, because the network's intent is distributed across every surviving unit. This is the R-swarm equation. It's the mathematical foundation of graceful degradation, allowing a swarm to stay operational under heavy fire. If a defense battery destroys 90% of the swarm's nodes, the remaining 10% instantly reroute their network and continue toward the target. The industrial math is even more lopsided. Adversary facilities are now producing 5,500 of these loitering munitions every month. When you compare that volume to the 2-year lead time for a single Western interceptor, the strategic imbalance becomes clear. These systems aren't built to win dogfights. They are engineered to empty the defender's magazines and make the cost of protecting a region higher than any nation can afford. This economic exhaustion is forcing a shift in global strategy. When every hour of military presence consumes years of production, conventional operations become a resource trap. We're already seeing the pivot. In Washington, aggressive talk of intervention has given way to multi-billion-dollar diplomatic reconstruction packages. It is an attempt to manage trade routes that can no longer be defended by force. Leaders can no longer justify risking a $100 million jet in airspace flooded by $25,000 drones. The cost-exchange ratio has simply collapsed. The result is a new reality where regions are no longer controlled by rival air forces, but are effectively walled off by the mere presence of cheap, persistent aerial minefields. How do you protect critical infrastructure when traditional air defense systems are economically bankrupt? The answer is a shift toward low-signature fortification and off-the-shelf maintainability. Instead of specialized military gear, defenders are repurposing civilian infrastructure, like shipping containers, burying them to hide from thermal sensors. They are also using passive kinetic shielding. Heavy industrial wire mesh and agricultural bird netting are being used to catch and detonate drones before they can strike their primary targets. This shift marks the end of an era. Strategic dominance is no longer determined by the technological sophistication of a single platform, but by the brutal math of industrial volume and network resilience.